Hello everyone, I'm Kaku. Today we are going to learn about a special kind of functions called one-on and onto functions. This video will be helpful for those students who are preparing for IIT JEE, CUET and other maths related competitive examinations. First, I will explain the definitions and we'll discuss some examples. Then I will move on to the counting of one-on and onto functions, and then we'll discuss some important results, and I will solve a few previous year questions asked in IIT JEE, and at the end of the video I will give some homework problems. Okay. The definition is one-on function is this. A function's f of a to b is said to be one-on. A one-on function is sometimes called injective function also, if different element of A has distinct images in B. Mathematically, the meaning of this definition is, for any two element x1 and x2 belongs to A, if their images is equal, that means f of x1 is equal to f of x2, then their pre-images should be equal. That means what? x1 should be equal to x2. Correct? Let me describe the definitions of one-on functions with the help of a pictorial diagram. A function f of a to b is said to be one-on if any two distinct element of a, that means say x1 and x2, they are distinct. That means they are different. Their images f of x1 and f of x2 must be distinct. That means different. Okay, then f is said to be one-on. The negations of this pictorial diagram is this statement. Okay, a function's f of a to b is called many-one if it is not one-on. Let me discuss some examples. A be a set with three elements a, b, c, and b be a set with three elements p, q, r. Okay, f1 is a map from a to b. The image of a is q, image of b is r, image of c is p. See, this f1 function is one-on because any distinct elements of A has distinct images in B. Correct? So this is one. Okay. Here, any distinct element of A, capital A, has distinct images in B. Correct? Because f of a is q, f of b is p, f of c is r. So it is 1. Correct? The image of a is r, but the image of b and c is q. So the image of b and image of c is same. So f3 is many-one. Correct? f3 is many-one. And the image of a and image of b and image of c is q. So this function is what? Many-one functions, correct? This function is many-one functions. F4 is many-one functions. Here observe one thing. This type of function is called constant functions, right? Constant functions is always many-one functions. Okay. Observe this. F is a function from A to B. F is either one-on or many-one. Correct? F is either one-on or many-one. That means what? That means what? Number of total function from A to B is equal to number of one-on function from A to B plus number of many-one function from A to B. This is an important observation, important results. Please mind it. I have questions to all. A is a set of 4 elements A, B and C, D. B is a set of 3 elements P, Q and R. Is the functions f of a to b 1? This is my questions. See, this is not 1, this is a minimum functions. Why this is minimum functions? Let me explain. The definition of 1 is what? Any distinct element of A should have distinct images in B. Correct? But here the number of elements is the number of element of A is 4, the number of element of B is 3. Correct? If A is mapped to Q, B is mapped to R, then C and D must map with B, because this is a functions. Correct? Every element of the domain should uniquely associate with a element of B. Correct? So this is a simple observation. What is the observations? If numbers of element of A is greater than numbers of element of B, then F is minimal. Move to other examples. Let f is a function from n to n defined by f of x equal to x square plus x plus 1. We have to we will say that whether this function is 1 or not. Correct? For this, only using the definitions. We will first let two distinct numbers in a domain. If their images are equal, then their pre-images must be equal. That means x1, x2 for being 1, right? We have to say that if f of x1 is equal to f of x2, then x1 equal to x2 holds or not. Correct? x1 square, x1 plus 1, x2 square plus x2 plus 1. The image of f of x1 is this, image of f of x2 is this. x1 square minus of x2 square plus x1 minus of x2 will be 0. x1 minus of x2, x1 plus of x2 plus 1 is 0. Either x1 equal to x2 or x1 plus x2 will be minus 1. This is impossible. Why this is impossible? Because minus 1 does not belongs to where? Minus 1 does not belongs to a domain. Correct? So this is impossible. The possible case is x1 equal to x2. So by definitions, this function is f is 1. The next example is let f is a function from n to n defined by a functional equation f of n plus 1 equal to f of n plus f of 1 for all n belongs to n. We have to say that whether the functions f is 1 or not. Correct? Okay. Let's simplify these functional equations. Okay. The put for n equal to 1. Put here what is the value of, if we put n equal to 1, f of 2 equal to what? F of 1 plus f of 1, 2 of f of 1. Correct? For n equal to 2, here 2 plus 1, 3, f of 3. Here f of 2 plus f of 1. F of 2 is what? 2 of f of 1 plus f of 1 is 3 of f of 1. Correct? Similarly, for n equal to 3, f of 3 is, f of 4, f of 3 plus f of 1, f of 3 is 3f1 plus f1 for f of 1. Correct? And proceeding similarly, f of n equal to n of f of 1 for all n belongs to n. Correct? We find a relation. Now we will say whether this function is 1 or not. Correct? Let n1, n2 belongs to n, then f of n1 equal to f of n2 equal to n1 f of 1 equal to n2 f of 1. Since f of 1 is a natural number, so this will cancel out, n1 equal to n2. By the definitions of 1, directly say that f is 1. We only using the definitions of 1, correct? Okay. Now next we'll move on to the next topic, the counting of one-on functions. Okay. For example, let A be a set with 3 elements A, B, C, and B be a set with 4 elements X, Y, Z, W. And the question is that find the number of one-on function f of a to b. Okay. How can we solve this? Okay, let's do a pictorial diagram here. F of a to b, a, b, c, x, y, z, w. Here, what is the definitions of one-on functions? Distinct element of A has distinct images in B. Correct? Okay. Now let's observe. A has 4 choices, right? The image of A has 4 choices. Image of A, maybe image of A, maybe Y, maybe Z, and maybe W, right? Image of A has how many choices? 4 choices. Then image of B has how many choices? Suppose image of A is Y. Image of B has 3 choices because image of B cannot be Y because the function is 1. Correct? So image of B has 3 choices. Suppose image of B is X. Correct? Then the image of C has how many choices? 2 choices because image of C cannot be Y, cannot be X because F is 1. Correct? Image of C has 2 choices. Therefore, the number of possible one-on function from A to B is 4 into 3 into 2, which is how much? 20. How many? 24. Okay. Next, we'll do the generalized case of this. Suppose A has m elements, A1, A2 up to Am. And suppose B has n element, B n. Then find the number of one-on functions from A to B. Remember that here m is less than or equal to n. If m is greater than to n, then this function is many one, not one. Okay. Now we have to find the total number of possible one-on functions from A to B. Let me draw a pictorial diagram here. F A1, A2, and Am is here, B1, B2, and Bn is here. Right? Image of f of A1 has how many choices is here? N choices, right? The image of f of A1 may be B1, maybe B2, it can be Bn. Correct? Has how many choices? N choices. Correct? Then suppose image of A1 is B3. Suppose. Okay? Then image of A2 has how many choices? N minus 1 choices, because image of A1 is B3. If image of A2 is B3, then the function will not be 1. Correct? This is 1 function. Will not be 1. Okay? So f of A2 has n minus 1 choices. Okay. Similarly, suppose f of A2 is B1. Suppose we are only assuming here. Then f of A3 has how many choices? f of a3 has n minus 2 choices, because f of a3 cannot be b3, f of a3 cannot be b1, because the function is 1 1. N minus 2 choices. Proceeding similarly, f of am has how many choices? N minus m plus 1 choices. Correct? Look at here. Observe, f of a1 has n choices, f of a2 has n minus 1, right? a3 has n minus 2. Correct? Subtracting 1 now. Okay? M has how many choices? N minus of m minus of 1 choices. That means n minus of m plus 1 choices. Correct? Therefore, the total number of 1 function is from a to b is how many? N minus 1, n minus of 2 into n minus of m plus 1. Okay? N into n minus of 1. Now we can multiply here 1. Correct? N minus n plus 1 and write 1 like this. N minus of m factorial, n minus of m factorial. Correct? Okay. What is this? From n into n minus 1 into n minus of m plus 1 into n minus of m factorial is n factorial, and this is n minus of m factorial. This is nothing but this is n e m. We get a new formula. If we have a set of m element, if you have a set of n element, provided that m is less than or equal to n, then the number of 1 functions from a to b is how many? N, p, m. Okay. Last question was that what? That cardinality of a is, number of element of a is 3, number of element of b is 4. The number of 1 functions from a to b is 4p, 3. What is 4 factorial? 4 minus of 3 factorial. This is 4 factorial. This is 20. Example 3. Let A is the set A1, A2, A3, A4. B is the set containing 5 elements B1, B2, B3, B4 and B5. Then number of 1 function from A to B such that f of A1 cannot be B4 and f of A2 is B1. These are interesting questions. Okay. How can you find that? We have to find, we are given that a set with 4 elements, a set with 5 elements, then we have to find the number of 1 functions from A to B such that these two conditions satisfied. The image of A2 must be B1, the image of A1 cannot be B4. Right. Let me draw a pictorial diagram quickly. F is here, A and B is here, A1, A2, A3, A4, B1, B2, B3, B4 and B5. The given condition is that the image of A2 is B1. Correct? This is fixed. Okay? The image of A1 cannot be B4. This cannot happen. So A1 has how many choices? The image of A1 has how many choices is here? Because image of A1 cannot be B4. Right? F of A1 cannot be B4. These are the given conditions. And also F of A1 cannot be B1 because it's a 1 function. Correct? So image of A1 has how many choices is here? 3 choices. 3 choices, right? And f of A2 has only 1 choices. Okay? 1 choices. Correct? F of A3 has how many choices? How many choices here? F of A3 cannot be B1, correct? If f of A1 is B2, suppose, then f of A3 can be B3, B4 and B5, correct? F of A3 has 3 choices. F of A4 has how many choices? F of A4 has 2 choices. If f of A1 is B2, f of A3 is B3, then f of A3 has 2 choices, B4 and B5, correct? 2 choices. The number of 1 function f of A to B is how many? 3 into 1 into 3 into 2, 6 3 are 18. This question is asked in 2024 in JEE Mains. Okay. The question is that A is a set having element 5 element 1, 3, 7, 9 and 11, and B is a set having 7 element 2, 4, 5, 7, 8, 10, 12. Okay. Then a number of 1 functions from A to B such that f of 1 plus f of 3 equal to 14. The image of 1 plus the image of 3 should be 14. Okay. The condition is take. Let me draw a pictorial diagram quickly to visualize this problem. 1, 3, 7, 9, 11, 2, 4, 5, 7, 8, 10, 12. Okay. Now, okay, case 1. What is the case 1? If image of f of 1 is 2, then image of f of 3 is what? 14 minus f of 1 is 2, will be 12. Then f3 will map the image of f3 is 12. Correct? Next, if image of f of 1 is 4, suppose if image of f of 1 is 4, okay, then image of f of f3 will be what? 14 minus 4, 10. Image of f of f3 will be 10. Okay. Case 3, if f of 1 is 5, then f of 3, 14 minus 5 will be 9. Observe that 9 does not belongs to the codomain set, correct? In B. So this will never happen. This case is impossible, right? Next, the fourth case, if f of 1 is 7, then f of 3 will be what? 7, 14 minus 7, it's 7. If f of 1 is 7, then f of 3 will be 7. This is not possible because f is 1. We have to find that the number of 1 functions. So f must be 1. So this case is impossible. Correct? Case 5, if f of 1 is 8, then f of 3 is 14 minus 8. How many? This is 14 minus 8 equal to 6. Correct? 6 does not belongs to B. Correct? So this case is not possible. It is an impossible case. 6, if f of 1 is 10, then f of 3 will be 4. If f of 1 is 12, then f of 3 will be 2. Correct? These 4 cases cannot be happened. Correct? We can merge these 2 cases with these 2 cases. How we merge? If f of 1 is 2, f of 1 has two choices. F of 1 may be 2 or it may be 12, right? F of 1 has two choices here. Then F of 3 will be two choices here. Merging this 1 and 6, correct? We merge this. Okay. Now f of 1 is 12, then f of 3 is 2. If f of 1 is 12, then f of 3 is 2. Correct? Sorry. I erase. F of 1 is 8, f of 1 is 10, then and f of 3 is 4, right? Merging 1 and 7, we get this, right? We get these conditions. Suppose this is named case 1. Okay. Merging 2 and 6, we get then f of 1 has two choices 4 to 10, then f of 3 has two choices 10 to 4. We get this case. Right? These three cases impossible. So I will erase this impossible part and the merging part. This is case 2. This is case 2. Okay. Now we will find the numbers of possible one-on functions such that the image of f of 1 is 2 and 12, 2 or 12, and the image of f of 3 is 12 or 2. Okay. For case 1, image of f of 1 has two choices, right? Two choices. Image of f of 1 has two choices, that is 2 or 12, right? So f of 3 has how many choices? Only one choice. If f of 1 is 2, if f of 1 is 2, then f of 3 cannot be 2. F of 3 must be 12 because of these conditions and the one-on conditions. Okay, one choice here, and other choice f of 7 has how many choices? If f of 1 is 2, f of 3 is 12, then f of 7 has 5 choices. F of 7 may be 4, 5, 7, or maybe 8 or 10. Correct? 5 choices. Similarly, f of 9 has 4 choices. Similarly, f of 11 has how many choices? 3 choices. Okay. Therefore, the number of one function from A to B such that case 1 satisfy, conditions of case 1 satisfy is how many? 2 into 1 into 5 into 4 into 3. 10, 12, 120. Correct? 120. The number of one-on functions from A to B such that the conditions of case 1 satisfy 120. Okay. Now let's come to the case 2. Similarly, we can find the case 2 also. Here, the choices of f1 has two choices is same. Two choices f1 has, right? If f of 1 mapped with 4, then f of 3 must map with 10. Correct? So f of 3 has only one choices. Correct? F of 3 has only one choices. Then f of 7 has how many choices? 5 choices. F of 9 has how many choices? 4 choices. F of 11 has how many choices? 3 choices. This is 120. The answer is the total number of one-on functions from A to B such that this condition satisfy 120 plus 120 to 40. Correct? It is an interesting question asked in JEE Mains 2024. Now the next example is A set has 4 elements 1, 2, 3, 4 and B set has 4 elements 1, 4, 9, 16. The question is that the number of many one functions from A to B such that one belongs to the range of A. One belongs to the f of A. This question was asked in JEE Mains 2025. How can we solve it? Let me draw a pictorial diagram here. Here F, A and B, 1, 2, 3, 4 and 1, 4, 9, 16 is here. Correct? Remember one observations. Okay. What is the observation? The number of total function is equal to number of one function. Number of total functions from A to B is number of one functions from A to B plus number of many one function from A to B. Yes. Okay. Remember these observations. Number of total functions is equal to number of one functions from A to B plus number of many one functions from A to B. Correct here? We have to find the numbers of many one functions, right? So we'll subtract the total. We'll subtract one functions from A to B from the total number of functions. Then we'll get the number of the total number of many one functions. And then what we will do? Then we'll remove this element from this whole set of B. Then we will find the numbers of functions from A to the set B, the set which is containing the element 4, 9 and 16. Then the number of these functions from A to the new set will subtract it from the total numbers of many one functions from A to B. Okay. Let me do it. The total number of functions from A to B. How many? See, 1 has 4 choices, right? 1 has the image of 1 has 4 choices, the image of 2 has 4 choices, the image of 3 has 4 choices, and the image of 4 has 4 choices. Correct? This is 256. Correct? Okay. Let me erase this. This is 256. Now the total number of one functions from A to B. What is it? P4, P4. What is it? 4, P4. 4 factorial by 1 factorial. 4 factorial. This is 24. Correct? So this is 24 plus. Let x be the number of many one functions from A to B. This is x. Correct? This is x. What is the value of x? The value of x is 256 minus of 24. What is it? 232. The number of many one functions from A to B is 232. Now, next, what we will do? I will remove. Suppose 1 does not belong to f of A. Suppose, correct? Then the number of functions from A to B is, will exclude this. Okay? F of 1 has 3 choices, f of 2 has 3 choices, f of 3 has 3 choices, f of 4 has also 3 choices, 81. Correct? That means these are the all functions like this 1, 2, 3, 4, 1, 4, 9, 6. These are the all functions such as 1 mapped with 4, 2 mapped with 9, 3 mapped with 4, 4 mapped with 16. Correct? This type of function, this type of collection of function is this 81. Correct? Now we will remove this type of functions from the total number of minimum functions. Okay? Now required solution is x minus 81. 232 minus of 81, which will be what? 151. Correct? Yeah, 151. 151 is the correct answer. Okay. See, next examples. These questions was asked in JEE Mains 2021. The question is that define x is the number of one-on functions from f of a to b having cardinality of a equal to 3 and the cardinality of b equal to 5. Y denotes the number of one-on functions from f of a to a cross a. Then which one of the following is true? Okay. This is a very easy problem. X is what? Number of one-on functions from a to b. The cardinality of b is 5. The cardinality of a is what? 3. So 5p3. 5p3. How much? 2 factorial. 5 into 4 into 3. 60. Correct? Okay. Y is the number of one-on functions from a to a cross b. We need to find how many. We need to find the cardinality of a cross b. What is the cardinality of a cross b? A cross b have numbers of element of a into numbers of element of b times element. Okay. 3 into 5, 15 elements are there. Now the numbers of one-on functions from a to a cross b is 15p3. That means 15 factorial, 12 factorial. Correct? 15 into 14 into 13. Now 14 can be written as like this: 15 4 into 14 by 4 into 13. Correct? 60 is x. Replace 60 by x and 7 by 2 into 13. Here what is twice y equal to 91x. Twice y equal to 91x. This is the correct answer. Now next move to the another topic. F is 1 if and only if any line parallel to x-axis cut the graph at most 1 point. Okay. Let's understand these results with the help of examples. Few examples. F of r to r, f of x equal to x square. Correct? The graph of this function is like this. Correct? If we draw any line parallel to x-axis, suppose this line, cut the graph 2 points. So this function is not 1. Why this is not 1? Suppose here is the point 4. 4 is here. Correct? 4 is here. Minus 2 is here. Minus 2 is here. That means what? F of minus 2 is also 4. F of 2 is also 4. That's why this function is minimum, not 1. Okay? Consider your functions f of r to r, f of x equal to e to the power x. This function. correct? Here x-axis denote the domain and the y-axis denote the range of this function. Okay, if we draw a function, if we draw a line parallel to x-axis, here it cuts the function at most one point, correct? Suppose this is small y and this is small x. Small f of x has only one image, that is y. So this is 1. Okay, and we can say that f of r plus 2r f of x equal to log of a base x. This is also a one-on function, correct? A greater than 1. If we draw some lines parallel to x-axis, it will cut the graph only one point. Okay, when a is greater than 0 and less than 1, then the curve of log x is look like this. Any line parallel to x-axis will cut the graph at most one point. So this function is 1. Okay, f of r to r, f of x is mod x. This function is minimum. Why? Suppose this is y equal to 2 line, right? 2, it has 2 images or 2 pre-images, plus 2 and minus 2. That is f of minus 2 equal to f of 2 equal to 2. Now let's come to the next important result. This is a continuous function f has a local maximum or a local minimum, then f is minimum. A continuous function f which is strictly increasing or decreasing over the whole domain, then f is 1. Let me give some examples of the result too. Suppose this is a function. We know this function is minimum, correct? This function f of x equal to log x function, correct? At x equal to 0, f of x at x equal to 0, f has minimum, correct? So this function is minimum. This is sin x function, correct? This function is also minimum because at x equal to pi by 2, at x equal to 3 pi by 2, at x equal to minus of pi by 2, x equal to minus of 3 pi by 2, the function sin x attains its maximum and minimum value. That's why it is minimum, correct? By the graphical method, we can directly say that this function is minimum because any line parallel to x-axis cut the graph 2 points, right? Any line parallel to x-axis cut the graph here, it's infinitely many times, correct? The domain of the function is the function, both functions are from R to R. Okay, here suppose there is a function, there is a quadratic function, there is a cubic functions like this. Okay, this cubic functions attains its maxima, suppose x equal to a, and minima, suppose x equal to b. Then this function is what? This function is minimum. Okay, not 1. Here, let's say a continuous function f which is strictly increasing or decreasing over the whole domain, then f is 1. See, strictly increasing, the meaning of strictly increasing is what? F dash of x greater than 0. Correct? The meaning of strictly decreasing is what? F dash of x less than 0. Here the slope is positive, here the slope is negative. Correct? Let me show something. Here, some examples. Here, f of x equal to x cube. This is the increasing functions on the interval. Here, e to the power x. This is increasing functions. Here, e to the power minus of x. This is decreasing functions. Because here f dash of x is e to the power x and the range of this function is r positive, correct? So this is positive. So this function is strictly increasing. Here 3x square f dash of x, this is positive, correct? So this function is strictly increasing. Here this function is not strictly increasing because this part is positive, but this is minus here, right? Decreasing. And let me give one example here. Suppose a function like this, correct? Here at this point, this function attains this maximum x equal to a, correct? At this part, this function is strictly increasing, f dash of x. Okay, this function increases, and this part, this function is f dash of x is strictly decreasing, correct? So there is a point where f dash of x will be 0, right? Then the slope is 0. That means at x equal to a point, the tangent on the curve of f is parallel to x-axis. Okay, that's why it will attain maxima at x equal to a point. Here a function f which is strictly increasing or decreasing over the whole domain, not simultaneously increasing or decreasing, okay, either increasing or decreasing over the whole domain, then this function is called one-on function. Let's move to the definitions of onto functions. Onto functions. Okay, a function f of a to b is said to be onto if every element of b should have a pre-image in B. That is what mathematically the range of f is the codomain B. This is the codomain, correct? It is the range of A is codomain. Okay, let me solve one examples of onto functions here. These questions was asked in JEE Mains 2019. A functions f from r minus plus minus 1 to a. Here the domain does not contain plus minus 1. Correct? Note that defined by the functions f of x equal to x square 1 minus of x square is surjective. Here write onto functions, sometimes called surjective functions. Okay. Then what is the range of A? Okay. We'll find the range. How can you find the range? Let, we all know that. How can you find the range? Let y equal to f of x equal to x square 1 minus of x square. We'll find a value of x here. Correct? So y minus of y x square equal to x square. X square equal to 1 plus of y equal to y. X equal to root over plus minus y 1 plus of y. This function is valid only f of x greater than or equal to 0. Here this function will be valid only where y divided by 1 plus y greater than or equal to 0. Correct? Okay. Let's see here at y equal to 0, this is hold at y equal to minus 1. At y equal to minus 1, the functions cannot be defined here. Now, at which interval y by 1 plus y will be positive? Let's see. For this interval, y greater than or equal to 0, this map always this functions always positive, correct? Okay, for y belongs to -1 to 0, let's take -1.5 here, -1.5. Put the value of -1.5 here, minus of 0.5 here, 1 minus of 0.5 here. What will we get? We will get a negative value, correct? Here, this interval at y belongs to minus of 1 to 0. This interval, for this interval, this inequality does not satisfy for y belongs to -1 to 0. Now, for y less than -1, this inequality hold. Suppose we put -2 here and 1 minus 2 here, then this is -2 minus 1, this is 2, this is positive, right? Now, for y belongs to minus of infinity to minus of 1, union of 0 to infinity, these expressions hold, correct? What is the range of these functions? The range of this function is this. A will be what? The range will be r minus of -1 to 0. This is the correct answer. Let me move on another examples. Here this question is asked in JEE Mains 2025. These are recent questions. Let given a function f, the domain is closed interval 0 to 3 to a, and the range is a, be defined by f of x equal to 2x cube minus 15x square plus 36x plus 7, and z is, the domain is 0 to infinity and the range is b, right? G is defined from 0 to infinity to b, be defined by z of x equal to x to the power 2025 divided by x to the power 2025 plus 1 if both f and g are onto, then, and S is a set of all integers coming from the range A or range B. Then how many elements are there? How many elements in S? The question is this. Okay, we'll find this. F in these questions, F and Z are onto, right? Both onto. We have to find only the range of A and B. Then we will find this. Okay, this S. How can you find this? The range of this. Okay. What is the value of this f of x? F of x is 2x cube minus of 15x square plus 36x plus 7. Correct? Here f of 0 is what? F of 0 is 7 and f of 3 is what? 30. What is this? F dash of x is 6x square minus of 15x plus of 36 equal to 0. Then the critical point is x minus of 2, x minus of 3. Correct? The critical points are there. Because 3 is a boundary point and the value of 3 is 34. Good. So we will find the value of 2. F double dash of x will be what? 12x minus of 15. F double dash of 2 is F double dash of 2 is 15, not 15, this is wait 6 12x, sorry, this is 30, sorry, yes, double dash of 2, this is minus of 6. At x equal to 2, the function f attains its maximum, correct? Attains its maximum value at x equal to 2. Now f of 2 is what? f of 35, sorry, correct? That means what? This is a polynomial. The domain is 0, 1, 2, here the 3. Domain is 0, 1 to 3 here. The function change its nature, right? F dash of x equal to 0 at x equal to 2 and 3. The function change its nature at x equal to 2. Now the function changes its nature at this interval, correct? Suppose this is f of 2. Suppose f of 0 is what? 7. Suppose this is 7, the curve will go like this. F of 3. Correct? This is a onto functions and range of this is what? Range of this is 7 f of 2. That means what? Sorry. Yeah. 7, 35. The value of a is 7, 35. G of x is x to the power 2025, 1 plus x to the power 2025. It can be written like this: 1 plus x to the power 2025, 1. Correct? Now, here the domain is, right, x greater than 0, greater than or equal to 0, less than infinity. Okay, then x greater than or equal to 0, 2025, less than infinity. Correct? We'll 1 add 1 plus x 2025 less than infinity. Correct? Then dividing 1 plus x to the power 2025. Here note that this is equal to this is 1, correct? So if you reciprocate it, 1 to the power infinity is 0, correct? This is 0, and taking the negative sign, then this inequality will change, correct? This inequality will change, and adding 1, this will be 0, this is 1, minus of 1 plus of 1 x to the power 2025 less than 1, correct? The range of this function is what? G of x is less than 1. That means b is what? A close 0, open 1. Correct? Here b is close 0, open 1. Now we have to find the value of this set S. S is what? The set of all integers such that x is belongs to A or x is belongs to B. How many integers in A? How many integers in how many integers in A? B. First tell me. Only one integer, correct? 0. And how many integers in A? 7, 8, 9, 10, 11 up to 35. Here how many integers is there? 25, and here 4 integers is there. Here only one integer. Total how many integers is here? Numbers of S is 30. The correct answer is 30. Let's move to the another topic. Counting of onto functions. Onto functions. Correct? Okay, let's give me one example. Example 1. Let A be a set with n element. Suppose A1, A2 up to n. B is a set with 2 elements, B1 and B2. Then number of surjective map, surjective function from A to B is what? Now we will find the numbers of onto functions from A to B. Okay, let's draw a pictorial diagram so that we can easily understand the problem. Okay, here a1, a2 up to an is here, and here only two elements b1 and b2. Okay, what is the definition of surjective functions? The definition of surjective function is range of f is codomain. Correct? Here codomain is B. Okay. What is the here? There are two elements in B, right? These and how many functions are there? Total functions. A1 has two choices. A2 has two choices. Image of A1 either B1 or B2. Image of A2 either B1 either B2. So A1 has two choices, A2 has two choices, and lastly AN has also two choices. How many elements are there? N elements, right? 2 to the power n functions. The total number of function is number of functions from A to B is 2 to the power n. Among them there are two constant functions, right? One is like this and the another is like this. Correct? Here a1, a2 up to an. Correct? These are two constant functions which is not surjective. Correct? To remove this, 2 to the power n minus of 2. This is the answer. The number of surjective functions from A to B is 2 to the power n minus 2. Okay. Let's do another examples. Let A equal to let A be a set having 6 elements 1, 2, 3, 4, 5, 6, and B is a set having 3 elements x, y, z. The number of we have to find the number of surjective functions from A to B. Okay. How can you find that? Let me draw a pictorial diagram here so that we can easily understand the problem. Here 1, 2, 3, 4, 5, 6 and x, y, z. We have to find the number of onto functions. That means what? See, how many functions are there? The numbers of total possible functions. The image of 1 has 3 choices, image of 2 has 3 choices, image of 3 has 3 choices, image of 4 has 3 choices, image of 5 has 3 choices, image of 6 has 3 choices. That means what? This is 81, this is 9, 729. Okay? 729. The numbers of possible functions from A to B is 729. Among these 729 functions, we have to remove this kind of functions where mapping like this. Correct? Because this function is not onto, where among these 729 functions we have to remove this type of functions. Correct? We have to remove the constant functions also, because constant function is not onto. Okay? How can we count this, the number of surjective functions from A to B? Let's see. Solve these questions with the help of set theoretical concept. Okay, this is U. U is the universal set. Universal set means the possible numbers of functions. The collections of possible numbers of functions is the universal set here. Okay. Suppose this is a set A, this is a set B, this is a set C. A, B and C. A contains those kind of function 1, 2, 3, 4, 5, 6, x, y, z. A contains those kind of functions which have x does not belongs to in the image of A. Right? X does not belongs to the image of A. That means what? This kind of functions. A contains only this kind of functions and B contains this kind of functions. Okay, Y does not belongs to the range of A. Correct? Y does not belongs to the range of A. And C contains this type of functions where Z does not belongs to the range of. Now from here, A is a set where x does not belongs to a range of A, B is a set where y does not belongs to a range of A, C is a set where z does not belongs to a range of A. Then we have to exclude all this set A, B and C, A or B or C from U. Then we will find the total numbers of surjective functions. How can you find that? The number of surjective map. Sometimes map is called function. Function is map. Right? Which is synonyms. Okay. The numbers of element of U is numbers minus numbers of A union B union C. Okay. Correct. What is A union B union C? A union B union C. Number of functions. Number of functions where x is does not belongs to f of A or y is does not belongs to f of A or z is does not belongs to f of A. Okay. How can you find that? Find this number. We know that numbers of A union B union C equal to numbers of A plus numbers of B plus numbers of C minus of numbers of A intersection B minus of numbers of B intersection C minus of numbers of A intersection C plus numbers of A intersection B intersection C. Correct? Okay. Numbers of A. Numbers of A means the numbers of functions where x does not belongs to f of A. How many numbers is here? Let me do a pictorial diagram here. Here, see 1, 2, 3, 4, 5, 6, x, y, z. Z does not belongs to a range of A. Sorry, x does not belongs to a range of A. So, the possible choice of the image of 1 is 2. The possible choice of image of 2 is 2. F of 3 has 2 choices, 2. So, numbers of A is what? N is 2 to the power 6. Because f of 1 has 2 choices, f of 2 has 2 choices, f of 3 has 2 choices, f of 4 has 2 choices, and f of 5 has 2 choices, f of 6 has 2 choices. Correct? So, n of A is 2 to the power 6. Similarly, n of B is also 2 to the power 6. And f of C is 2 to the power 6. And A intersection B. See, the numbers of functions where x does not belongs to f of A and x does not belongs to x does not belongs to f of A and y does not belongs to f of B is how many? Here, see here, x does not belong to the range set and y does not belong to the range set. Only possible image is what? Z. Only one possible image. F of 1 should be Z, f of 2 should be Z, up to f of 6 should be Z. That means what? This is a constant function. Okay? Number of constant function is what? 1. Correct? Here, similarly, number of B intersection C is also 1. That means what? The numbers of functions where y does not belongs to the range of f of a and z does not belong to the range of f of a is 1. The number of functions from the number of set a intersection c is what? Also 1. Similar manner. And a intersection b intersection c is what? A intersection c b intersection c is the number of functions where f of x, where x does not belongs to f of a and y does not belongs to f of a and z does not belongs to f of a. Is this possible? Let's see here. X, y, z. If a function, the image of any element of a is not x, the image of any element of a is not y, the image of any element of a is not z. Is this possible? No. Correct? So this is 0. The number of the set A union B union C is what? 3 into 2 to the power 6 minus of 3. This is 3 into 2 to the power 6, 64 minus 1, 63, 9, 189. Okay. Here the number of surjective functions from a to b is the numbers of element, the numbers of possible functions from a to b is how many? 729. Correct? 729 and minus of this 189. 0, 4, 540. 540 is the correct. Next, there is a definitions. What is this? A function f which is both 1 1 and onto is called bijective function. Bijective functions. A function which is both 1 1 and onto is called bijective functions. For example, suppose f is a function from R to R, f of x equal to x cube. Correct? This is a bijective function because this is the graph of this function is look like this, and the range set is the real number itself, and any line parallel to x-axis cut the graph at most 1 point. So that this is the bijective function. R to R plus function of f of x equal to e to the power x. Correct? The range of this function e to the power x is r positive, so the range is equal to codomain, so it is onto, and any line parallel to x-axis cut the graph at most 1 point, so it is 1. This function is also bijective functions. Okay, let me do some examples related to bijective functions. Example 1. Suppose f is a function from n to n defined by f of n is n minus 1 by 2 and minus of n by 2 when n is odd and when n is even. This is bijective. This is a bijective function. Let's draw a pictorial diagram. Oh, sorry, this is not n, this is z. Here 1, 2, 3, 4, 5, 6, 7, 8. Look here 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Right? F of 1 is what? 0. F of 3 is what? 1. F of 5 is 2. F of 7 is 3. F of 2 is minus 1. and f of 4 is minus 2, f of 6 is minus 3. That means what? The image of all even numbers are odd numbers, correct? All odd numbers. The image of all odd numbers are even numbers. Okay, let's solve another examples of bijective functions. This questions was asked in the JEE Mains 2019. F and g be a functions of n to n defined by f of n equal to n plus 1 by 2 when n is odd, n by 2 when n is even, and g of n equal to n minus of 1 to the power n for all n belongs to n. The question is that whether this composition of functions f composition of g is 1 1 onto not 1 1 onto 1 1 not onto neither 1 1 nor onto. Okay. For solving this, I will erase this option, okay, because of lack of space. Solution, here f composition g of n is f of g of n, correct? Now when here g of n is what? When n is odd, g of n is what? N plus of 1. When n is even, g of n is what? N is even, g on 1, this is minus 1, correct? Now when n is even, then g of n is odd, correct? When n is even, then g of n is n minus of 1, this n minus of 1 is odd. It implies that f of g of n, gn is odd, right? For odd function we get what? N plus 1 by 2. So g of n plus 1 by 2 is here. For n is even, correct? N is even, for this even, g of n is what? N minus of 1. N minus of 1 plus 1 by 2. This is n by 2. When n is even, then f of gn is n by 2. Similarly, when n is odd, then g of n is what? When n is odd, then g of n is n plus 1. N plus 1 is even, correct? When gn is even, then f of gn is what? F of gn is gn by 2. F of gn is gn by 2. When n is odd, then gn is what? N plus 1. N plus 1 by 2. Okay. Here f composition g of n is what? N by 2, n is even, and n plus 1 by 2, n is correct. Now let's observe these functions. These functions f composition g of n is going to f composition g of n is defined from n to n, correct? For f of 2 is even. The value of f composition g of 2, because 2 is even, the value of f composition g of 2 is what? 2 by 2, which is 1. For f composition g of 1 is odd, the value of f composition g of 1 is 1 plus 1 by 2, that is also 1. That means what? Image of 2 and image of 1 are same. but 1 is not equal to 2, correct? They are not distinct. So this is not 1. F composition Z is not 1. Now we will check that whether this function is onto or not, correct? I will erase this part to calculate. Okay, erase this part for checking the onto condition. Let me draw a pictorial diagram here, correct? Here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is N, this is N, this is F. Sorry, this is F composition Z, correct? F composition Z of 1 is 1. F composition Z of 1 is 1. F composition Z of 3 is 2. 5 is 3. 7 is 5, correct? 9 is 7. F composition of Z of 2 is 1. F composition of Z of 4 is 2. 6 is 3. 8 is 5. That means any one element of the range N, any one element of the codomain N, we have two pre-images in the domain N. So this function is onto. Okay. Was asked in IIT JEE means 2022. The number of bijective functions from f of 1, 3, 5 up to 99 to 2, 4, 6 up to 100 such that f of 3 is greater than f of 9 is greater than f of 15 is greater than up to f of 99 is how much? Let me do a pictorial diagram to understand this problem properly. A is 1, 3, 5, 7 up to 99 and B is 2, 4, 6, 8, 100. Here we have to find the number of bijective functions, that is number of 1, 1 and onto functions, correct? So such that f of 3 is, the image of 3 is greater than image of 9 is greater than image of 15. Suppose the image of 3 is 100. Suppose if the image of 3 is 100, then image of 9 is less than image of 100. Say image of 9 is 98. Then image of 15 is say 96. Image of 15 is less than image of 9, like that. We have to find the number of bijective functions satisfying these conditions, this type of conditions. Okay. Now, first we will calculate how many numbers are there who is satisfying these conditions. Okay. How many numbers are there? 3, 9, 15. This is a arithmetic progression with difference, with common difference 6. The last term is 99. The first term is 3, and we have to find the value of n, that is number of term, and the common difference is 6. Correct? 96 by 6 plus 1 equal to n, and equal to 16 plus 1 17 here. Correct? There are 17 numbers here. Okay. Now, this image of 17 numbers in the domain are arranged in decreasing sequences. Okay. How can we arrange that? Number of ways of images of 3, 9, 50 up to 99 can be arranged. How many ways? 50, C, 17 ways. There are 50 elements here. Okay. among these image of 50 element of A, we have to arrange the images of this 17 element in such a way that this given conditions satisfy. Alright, this is this. And the remaining 33 element of the domain can be arranged how many ways? Suppose this element are arranged 56, 17 ways. Then f of 1 can be, f of 1 has how many choices? F of 1 has how many choices? 17 numbers are gone from B. Then how many numbers are left? 33 numbers are left. 33 choices. Since f is 1, so image of f of 1 cannot be image of f of 5. The image of f of 5 has how many choices? Has 32 choices. Then image of 7 how many choices? 31 choices. So the remaining elements has the image of remaining element. The image of remaining 33 element in A, how many choices? Has 33 factorial choices. Okay, and a number of bijective functions from this set to this set. Suppose this set is A, this set is B. Then the number of bijective function from A to B is 50 C 17 into 33 factorial. That is the answer. These three are homework problem. I think you will like this video, and thank you.